Hello and welcome to 2.4 Solving Multi-Step Inequalities. Let's get rolling. This is going to be very similar to solving multi-step equations. Don't forget your one difference with solving these inequalities is that you have to flip the sign if you multiply or divide by a negative. So keep that in mind. Other than that, let's roll with it. I'm going to pick sides. Got more x's on the right, so I'm going to put my x's on the right. And with inequalities, it's even more beneficial to you to go to the side with more x's or more variables because you won't have to flip that sign when you divide by a negative. So even better for you. So let's subtract 2x from both sides. That will remove my x's from the number side. And we're left with negative 3 greater than or equal to 2x plus 1. And looks like I've got all of my x's out of the left side. So let's go to the right side. Those should be all x's. And I've got some numbers there. So let's get rid of that plus 1 by minusing 1 from both sides. Negative 3 and negative 1. Put them together. You get negative 4 greater than or equal to 2x. Divide both sides by 2. Ooh, wait, hold on. We're dividing and there's a negative. Do I need to flip that sign? Good. You weren't fooled. You're not dividing by a negative. You're dividing by 2. And that's not a negative. We are dividing a negative 4, so we have to keep in mind a negative divided by a positive is a negative, but we don't have to flip our inequality sign. Let's say I wanted to graph this also, because why not? Graphing is so much more fun, gives us a nice visual representation. I'm going to put a closed circle on my negative 2 because the x is also equal to negative 2, and I'm going to shade to the left because I want to look and see that my x's, turn it this way here, my x's are less than, the small part of it's toward it, so it's less than negative 2, and the numbers that are less than negative 2 go to the left. Moving on to number 2. Ooh, this guy looks kind of funky. Whew, what's going on here? All right, let's get started. So we're going to first distribute that 2 in and get 6x minus 4. And on the right side, I don't have any distributing, but I've got 3 terms, and usually I'm only going to end up with 1 term, so I should be able to combine 2 of these. Let's see, 4, I can't do that, but this 4 and this 3 I could, couldn't I? So I'm going to put those together and get 7, and I still have a minus 2x right there. And I'm going to have to pick some sides. I like the left side to be my x side because I've got 6 of them over there, and the right side's got negative 2, so it's getting beat pretty good. So left side, we can work on either side first. That doesn't matter. I'm going to work on the left side, and this is my x side, so the negative 4, that has got to go. Add 4, add 4. See, we're left with 6x is less than 11 minus 2x. Now I'm going to look at this. Let's see, on the right side, I've got to move those x's over, so add 2x to both sides. 6, 7, 8x is less than 11. And now, I'm going to have a messy little fraction here. That's okay. 11 over 8. It's a little more than 1, right? Maybe a 1.5-ish. Almost 1.5. Okay, so if I want to graph this, it really doesn't matter. You can just put 11 over 8 there. I know it's positive, so. And I'm going to put a open or closed circle. That's right, open circle on the 11 over 8. And I'm going to shade which way? I don't hear you. You could talk to a computer, even if you're by yourself. That's okay. Yes, that's right, to the left. To the left, because x is less than. So I'm going to shade to the left. So that's all the just sort of straight up, work them out problems I'm going to do. I'm going to move on to word problems because I feel like these are the ones we really need to spend some time on. So, talking about the area of a rectangle, and I know we're doing inequalities here. So it's talking about the area of this rectangle. And so when I see that, I'm thinking, okay, area of a rectangle, that means I'm doing length times width, or length times width. It's not really important which one's length and which one's width because we're multiplying them together anyway. So anyway, it tells me the length is, or the area must be at least 119 square units. And so what are the possible values of x? So let me just start with, I know length times width equals area, and it gives me this 119 for my area, and I know my length and width are 7 and 6x minus 2, so I can kind of lock all that stuff in. And now I'm thinking it's got to be some sort of inequality sign in between them. So let's be careful here. It needs to be at least 119. So let's go back to at least, and it's, you got to be careful on this one because that really looks like less than. Least and less than, they're very similar. But when it says at least, you're really saying you want it to be more than this number. You're saying this is the bottom number it can be. I'd really like it for it to be greater than this number. So when I multiply these two things together, it's going to be greater than or equal to, because when you say at least, it's saying that that's a possible answer. It's the lowest possible answer, but it's a possible answer. 119. So that's going to be my setup here. And then I'm going to multiply this in. 7 times 6x gives me 42x's. And 7 times negative 2 is negative 12. Greater than or equal to 119. Add 12 to both sides. 42x greater than or equal to 131. And I'm going to get out the calculator for this one. Let's see, we've got 131 divided by 42. That gives me, oh, I had a decimal in there. 3.12 looks like. So x is, let me show my work here. Divide by 42, divide by 42. X is greater than or equal to 3.12. So that would be your answer. Now you might want to plug this back in and think, is that going to give me something good? Let's see, 3 and a little bit, so 6 times 3, 18 minus 2, 16, might be 17 or so by the time we put that decimal in there. 17 times 7, let's see here, 17 times 7, I don't know my 17's type of tables, is 119. So that looks like a good number that we've got right there. And I want my number, my x, to be greater than or equal to 3.12 because we'd like the area to be at least 119 square units. So that looks good. Let's move on to the next one. Good old Gabe. Gabe is rehabbing his knee. Seems a little young to be rehabbing a knee, but it's all right. And the doctor said he should run no more than 3 miles per day. So you're rehabbing it. You might want to say, hey, let's not go too crazy. You could injure it again. No more than 3 miles per day. Gabe runs 7.3 miles per hour on average. How many minutes can he run for? So we're talking about distance, this 3 miles, and we're talking about a rate, which is miles per hour, 7.3 miles per hour, and talking about time, which are minutes. So we're thinking about distance and rate and time. What's that? Exactly. Distance equals rate times time. Yes. Well done. Okay, so now I know it's not going to be an equals because we're doing, you know, no more than, and so that tells me we're going to throw in an inequality sign. Um, my distance, what would that be? Is that my 3 miles or my 7.3 miles per hour? That's right, 3 miles. That's a distance. And then my rate is 7.3 miles per hour. And let's see, what else do I need to know? I need t, but that's just going to be, oh, I'm skipping slides here. T is just going to be t. And no more than 3 miles per day. So I want this stuff on this side to be no more than 3 miles per day. So we're trying to keep this down, this number here down. And so we're going to be putting the less than side toward that side. Okay? No more than. So 3 is greater than or equal to 7.3t. Okay? So then whenever I solve this, divide by 7.3, divide by 7.3, 3 divided by 7.3 is 0.411. So that's going to be my t value. And so what we're wanting to think about though here is it says how many minutes. Do you remember what we did last time when we had minutes and we got this? Because what's this? 0.411. Is it like half of a minute? That's not a very long time to run, especially to get 3 miles. That seems very fast. Not that I don't believe in you, Gabe, but I don't know. 0.411. It's not very long. Oh, you know what? We're dealing with miles per hour and 3 miles. So if this is in hours, we're talking about that's how many hours there. And so if I want to get down to minutes, I'm going to have to do something with this, right? And so we will need to find out this proportion or this kind of percent. What do we multiply by? Do you remember this? 60. Yeah, so we've got that 0.411 times 60, and that's going to give me 24.66. And now that is in minutes. So my t needs to be less than or equal to 24, we'll go to the nearest tenth here, 0.7 minutes. Okay, so no running any more than that. T, your time needs to be less than or equal to 24.7 minutes. Ooh, here would be fun. Do you know how to find how many seconds? Yeah, you just take off that 0.7 and multiply it by 60. So let's do that. 0.7 times 60. This is just for fun. This isn't even part of the problem. So now you're talking about 24 minutes. 24 minutes and 42 seconds. Wow, that's fun. That's fun. Do you kind of wish we would have had a decimal for the seconds? And then we could have gone even further? That would have been lots of fun. But I guess we go to tenths of a second, so I guess we could have left that as a decimal. So Anyway, that's the end of section 2.4. On 2.5, that's going to be a fun one right there. Compound inequalities. I'm looking forward to that. Talk to you guys later. Bye.